Hi everyone, in this video we talk about the Ligo types. So go to the ligolang.org website. On the top right you have a link to the web ID. Click on it. To get the code you can follow the Git link that you have here, or just start a default project with the jsLigo syntax. Let's start with the basic types. So here we start with a string, like in JavaScript. You have const for constant, the name of your variable of type string, and then you enter your string. Second type is a type bytes. So for the bytes you use the type byte, and you use the keyword bytes with backquote or backtick, and you enter here the string that you want to be in bytes. Next type is a type integer. Type integer is int, and you enter a number. The next type is the type natural, so is nat as a type, and you write a number and you add n at the end. Numbers, naturals, they are integers but only positives. Next type is a bit particular, is the type unit. So you can describe it like a void. The next type is the type boolean. In Ligo is bool, and its value is true or false. Next type is also special, we call it a variant. So you have to define the type and the enumeration of this variant. So it's an enumeration here. We have head or tail. And then when you have the type that is defined, you can use a variable like head, and you use the default constructor head here with parentheses to instantiate an enumerable. Okay, now we see the MIK types here of type Tez, which is a currency, the native currency, equal 0 Tez, for example. You can also represent the currency in the lowest decimal. Here is called mutez for 10 power minus 6 Tez. So here, if I have 1 million mutez, is the same like 1 Tez. Another type that you will manipulate is the type address. It's a specific string that represents user wallet account, TZ1 something, for example, or a smart contract starting with KT1 address. The next type is a time type. This called timestamp. For example, here I use the Tezos library to return me what is the current date, the date time in particular. Here I use the type list. So here is a list of integer, and I initialize this list with one element that is 0. Here another type like close to the type list is the type set. So I initialize here an empty set, and I define it like a set of integers. Another type is a type map. It's a key value store. Here I define a map of integer as a key and integer as a value, and with initialize with div values map.nt. Okay, that's most of the MIK types you have here. It's not an exhaustive list, you will see more later. Another kind of types you can see are annotations. They are not really types, they are just annotation that you can see just before a function, for example, or a structure. Let's have a look on these annotations. So here what we have a function that is an entry point, and we have an annotation that is just before the function, and it's named @entry, and it's very important for declaring an entry point. Let's see other kinds of annotations. I have two annotations here. The first one is called add layout. Here of type comp. So the layout, for example, is to represent the structure as a pair of pairs. It's like a tree of pairs in Michelson. The default one for structure is the layout comp, so you don't have in reality to declare it on a structure. It's just to show you that you can change this way of representation when the Michelson will be generated. You have also add a note. Add a note will change the way that the alias name on the structure for this field will be generated on Michelson. For example, here the name of the artist, by default you have a field name, so it will be name that will be generated on the Michelson, but because you have an annotation alias, it will change that to alias. So in the Michelson code you will have alias, on the Ligo code you will use name. Like in JavaScript, you have two ways of declaring variables. So one, they are constant and immutable, so you will use the keyword const, and the one, they are real variables and their content can change, so they are mutables, and you will use the keyword let. Let's see a small example. So here you have a declaration of a constant variable, so you cannot change its value. It will be always 0. In this last example, I have declared 4 variables with a let keyword. I initialize it to 0, but on the next line, I change the value to 1. So this is possible when I have a let declaration. Thank you for watching this video and see you next time.